Today we are going to discuss and solve problem number 11 from NeetCode 150, which is 2 sum 2 input arrays sorted. Let's jump into the problem. So this is the agenda of the today's session. Understand the problem statement, walk through the examples, discuss the brute force approach, and code the brute force approach, discuss the time and space complexity of the brute force approach. Then we'll discuss the optimal approach and we'll implement it, and we'll discuss the time and space complexity of it. So let's understand the problem. Given a one indexed array of integers, numbers that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. Let these two numbers be numbers of index 1 and numbers of index 2, where 1 is less than or equal to index 1 is less than or equal to index 2, less than or equal to numbers dot length. Return the indices of the two numbers index 1 and index 2 added by 1 as an integer array of index 1 comma index 2 of length 2. The tests are generated such that there is exactly one solution. You may not use the same elements twice. Your solution must use only one constant extra space. This is the main point that we need to note. We could think more approach, and we could think more approach and code, but the expected approach is that the algorithm should use only constant extra space, and it should be as optimal as possible. The time efficiency of the algorithm is as optimal as possible. So let's check out the constraints. So numbers dot length varies from 2 to 3 into 10 power 4, and numbers of I lies in between -1000 to 1000. Numbers is sorted in non-decreasing order, and target lies in between -1000 to 1000. The tests are generated such that there is exactly one solution. Okay, so let's walk through the examples. So these are the examples that I took. So in the first example, in this first input, numbers array contains 2, 7, 11, 15 and target equal to 9. So if I take 2 and 7, two numbers, when I add that number, I'll be getting the target, right? So I can simply return the indexes of that two numbers. Like I will need to add 1 to the index value, right? So index of 2 is 0, index of 7 is 1. So 0 plus 1, 1 plus 2 in this array. So I will need to return this array. So this is the output array 1, 2. So let's check the second example. So input numbers array contains 2, 3, 4 and target equal to 6. So if I take 2 and 4, when I add this, I'll be getting the target, right? So the index of 2 is 0 and index of 4 is 2. So I will need to return the index value plus 1 when I make a output array, right? That's why the output for this input is 1, 3. So example 3. So input numbers array contains -1, 0 and target equal to -1. So when I add -1 plus 0 is equal to -1, which is equal to target, right? So I will need to return 1, 2. 1 represents the index of -1 and 2 represents the index of 0, right? This is the one indexed array. That's why we are returning this thing. So I hope this is clear. Basically, we'll need to pick two numbers from the input array in such a way that when I add the two number, I will be getting the target value, right? So this is the task that we need to do. So what is the brute force approach that we can think, right? So I can write two loops, right? Simply I can write two loops and I can perform this task, right? So I is less than n I plus plus, and for int j equal to I plus 1 and j is less than n j plus plus. What I will be doing, if numbers of I is plus numbers of j equal to target, then this is the two numbers that I'm looking for. Then I can return straightly. At this point, I don't even need to continue or do anything. I plus 1 comma j plus 1. By default, we will be returning empty array. So that's it. So in the worst case, this particular algorithm will execute this thing. So numbers dot length, at the maximum it will be 3 into 10 to the power 4. So the time complexity of this brute force approach is, the time complexity is order of n power 2 and space complexity is order of 1, that is constant. Okay, so the So let's say there will be bunch of test cases will be executed when we submit our code. Let's say the larger input, right? The larger input at the maximum, the larger input will, like at the maximum, our algorithm will execute this particular amount of time, that is 9 into 10 power 8, right? So this is the maximum amount of time that our algorithm will take to execute, right? So for a larger test case, the algorithm might take this much amount of time, right? So let me submit this code, let me run this code. It should work fine. Let me submit this. See, it is submitted successfully. So the larger test case, so let me take the test case which contains 3 into 10 to the power number of inputs, like 3 into 10 to the power 4 is the size of the numbers array. This is the worst case. The numbers array will have this much amount of length, right? In that case, our algorithm will take 9 into 10 to the power 8, right? So the processor is capable of executing that particular test case, right? That particular test case in the specific time that is configured in the online bit. That's why we are not getting TLE. The solution is submitted, executed successfully. Just for a brief thing about what is TLE, let me show you this thing. So when we click the submit button, what will happen? So every online platform will have this online judge tool inside of it. So when we submit our code, our request will go to the online judge. What online judge will do is that it'll have bunch of inputs, and it will also have the corresponding outputs of each inputs, right? It'll request the processor, like it will give the algorithm and it will give the input. Processor will basically execute the code and it will return the response back to the online judge. Suppose if the processor is taking longer time, right? The time that is, if it is taking more time than the time that is configured inside the online judge, then what online judge will do? It will kill that particular processor and it will return the TLE error to the client, right? So that is what I just want to discuss. So here I made the statement, online judge is configured with a fixed time limit per test case. This is called the threshold time. So the threshold time is the maximum time allowed for your program to run for one test case. One test case, the algorithm should execute in a specific amount of time, right? So that is configured in the online judge. So time limit per test case is equal to 1 second. Then your program must finish processing each test case in under 1 second. It should not exceed more than 1 second. If it is exceeding, then we will be getting TLE error. So processor is designed to execute n number of operations per second, right? 1 second it might be able to execute 10 power 8 operations. So that n depends on how the processor is designed. If the processor is more powerful to execute more operations, then it may execute more 10 power 9 operations in 1 second. So it depends on the processor. So online judge will kill the requested processor when the processor does not return the result after the specific allocated time is elapsed. Then online judge will throw TLE to the client. So this is a very brief thing about like when we get the TLE error. Our case, the worst case time will be 9 into 10 to the power 8, right? So processor is executed successfully the larger input as well in 1 second. That's why we are not getting TLE error and our code is successfully submitted, right? So but this is not the expected thing. We should think of a better approach in such a way that it'll execute the particular in such a way that the algorithm will run in a optimal way, that is the time which is better than this quadratic, right? So what we can use is, so this is the brute force. Then let me quickly tell you the optimal approaches. So we could think of using a space we could create one hash map and we could store all the values inside of it. Right, so what I will be doing is equals 0, I is less than I plus plus. We can simply add the value inside the hash map. So numbers of I comma I. Then what we are going to do for again we'll need to iterate this input array, and what we will be doing is into needed value, right? So a needed value is what? Needed value is target minus numbers of I, right? So let's say here when I am traversing this input array, when I am at 2, the target is 9. If I have 9 minus 2, 7 in the input array, then I can simply return, right? I found the 2 numbers. That is what we are going to do. We are doing here. So if this hash map contains this needed value, then I found the 2 numbers, I can straightly return the answer, right? So hash map dot get of needed value plus 1 comma I plus 1. Let me run this code. Contains key, sorry. Okay, I should swap this thing. Okay, this should be successful. So I guess this logic is clear, right? So let's say this in this numbers array 2, 7, 11, 15, right? I am iterating this particular input array when I am at 2. So I am expecting if my input array contains 7, then I am good that I found the 2 numbers, right? So that is the logic, that is the approach, and that I implemented that particular approach here. So but the time complexity is optimized, but the space complexity is not optimized. Time complexity is order of n and space complexity is order of n. So we'll need to think of a better approach in which we could optimize the space, right? So what we will be doing, so since the input array is sorted, when the input element is sorted, everyone will think of using binary search, right? We could take the advantage of the array that is sorted, right? And we can apply binary search to perform our task. So that's one way we could use binary search. We could solve this problem using binary search since the array is sorted. So let's discuss the binary search approach, right? So let me take this particular input. So the binary search approach. So what we will be doing here, also we will be iterating the whole input array, that is this 2, 7, 11, 15. So when I equal to 0, 0, then the element value, then the number is equal to 2, right? I need if I could able to find 7 in this particular input array, then I'm good to return the answer, right? I found the 2 numbers. So this is initially what, in this particular case, this is our search space. So we will be pointing the low pointer here, and we will be pointing the high pointer here. So the middle pointer will be this one, right? So I am expecting 7. Is this middle is equal to 7? No, but it is greater than, right? It is greater than the so here when I am at number 2, I am expecting to search 7, right? But in this particular case, right, so the middle value is 11, right? But this is greater than the one that I'm expecting to search. What we will be doing in this case, we will be decrementing, we will be reducing our search space by moving our high pointer, right? So what we will be doing, so we will be high pointer, we will be moving. For that, what we will be doing, we'll be doing like this. So 7, this is the low and this is the high. Since the middle element is exactly equal to the element that I'm expecting to search, I can straightly return my answer, right? So similarly, when I is equal to 1, right? So in this case the value is found, so we'll be returning. But suppose let's assume that the particular the algorithm, so let's suppose if the two numbers is not found, the algorithm will continue executing, right? So number equal to 7, expecting to search will be what? Expecting to search will be search is equal to 2, right? My search space will be 11 comma 5. So this will be my low and this will be my high, and 0 plus 1 by 2, which will be 1 by 2, which is 0. So our middle is also this one, low comma middle. So this is the low and this is the middle value. So middle value is greater than the expecting to search, then we will be moving our low pointer. Actually here I cannot take this thing, since I found this number here, I will be returning from here, right? So I hope this binary search approach is clear. Let me code this one. Will try to explain you more clear as possible. So int low equal to 0 and int high is equal to 0 and int middle is equal to 0. So this is the binary search approach. Since the array is sorted, array is sorted array. So array is sorted. We are using binary search. Okay, fine. So we will be traversing this particular array. Int number 1 is equal to numbers of I. I am then expect int needed value. Int needed value is what? Needed value is equal to target minus number 1, right? So here low value will be I plus 1 and high value will be n minus 1, and I will be writing low is less than or equal to high, and middle is equal to what? Middle is equal to low plus high divided by 2. If suppose numbers of middle equal to needed value, then I'm good to return the answer. I found the value, right? So return new int array of I plus 1 comma middle plus 1. Else if numbers of middle is greater than needed value, in that case what we will be doing? Low equal to middle plus 1, else high is equal to middle minus 1. That's it. Let's run this code. Okay, let me comment out all the things that we written at the bottom. So the time complexity of this binary searches approaches n log n. Time complexity is order of n log n. So we are iterating the whole input array. For each iteration we are executing log n time of codes statements, right? That's why it is so this particular block will execute log n times. Since this is inside of the for loop, this will be executed n into log n. It is the and also the space complexity, and space complexity is order of 1, constant only. So we optimized the space, and we also optimized the space, but we are slightly increasing little bit. We increased our time complexity. So let me submit this code. Okay, let me run this code. This should work. If it is greater than, if it is greater, in that case I need to move my high pointer. If it is less than the needed value, then I will need to move the low pointer. This pointer movement is very, very important. We should carefully and correctly move the pointers. else it'll be difficult. So this should submitted successfully. See, this is submitted successfully. Fine. So can we also optimize the time a little bit more, right? We could since the array is sorted for this, but for performing this particular task we can use two pointers approach in that way. So two pointers approach, what we will be doing, let me also take this first example input. So I will be placing this left pointer in 2 and right pointer at 15th place, right? So initially left pointer at 0 and right pointer is at n minus 1, which is here is 3, right? So 2 plus 15 is equal to 17. This is greater, right? So since this particular thing is greater, but greater means what? This is greater than the target, right? In that case I will need to reduce the total sum. For that, what I will need to do, I will need to move the right pointer. In that way my total sum will be reduced, right? So after second iteration, left pointer is equal to 0 and right pointer, we will be moving the right pointer, that's why it will be 2. So 2 plus 11 equal to 13. Again this is greater than the target, right? Again we'll need to move the right pointer. So left pointer equal to 0 and right pointer equal to 1. So in that case 2 plus 7, which is equal to 7. This is equal to target. So we will be returning simply from in that point. So let's code this approach. So int left pointer equal to 0 and int right pointer is equal to 0, n minus 1. So while left pointer is less than right pointer, what we will be doing, int sum is equal to numbers of left pointer plus numbers of right pointer, right? If sum equal to target, then we can return simply from here. What we will be doing, left pointer plus 1 comma right pointer plus 1. Else if sum is greater than target, then right pointer minus, else left pointer plus plus. If it is less than target, we will be incrementing left pointer. If it is greater than the target, we will be incrementing the right pointer. Hope this should work as expected. Here, let me comment out this codes, this explanations. So I hope this is clear. I am placing the left pointer at the zeros, initially placing the left pointer at the zeros index and right pointer is at the end of the extreme end of the input array. And since we are taking two numbers, I should write left pointer less than right pointer, and sum is equal to numbers of left pointer plus numbers of right pointer. If this sum is greater than the target, then we'll need to reduce the sum. For that we will be moving our right pointer. If the sum is less than the target, we will need to somehow increase our sum. For that we will be moving our left pointer, right? So if it is equal to target, we will be simply returning. So this is the two pointers approach, and the time complexity is order of n, and space complexity is order of 1. This is the optimal approach and this is the expected one. See, the solution must use, this is the constant space and the time complexity is also linear. This should submit successfully. Yes. So that's it. Thank you so much for watching. I hope this is helpful to you. Thank you again.